saying here that things are equal widths and heights. That's what these little equals rules means. But there's also tiny little I-beams right up here that are showing the spacing to nearest neighbor. And also look, there's a lot of yellow here. This yellow, remember, means, yeah, there's constraints on these, but they're not actually where they're supposed to be based on those rules. So we really want to move them all to be in their proper spaces based on these rules. That's what these dashed yellow lines mean. So we're going to do the same thing to do that we did at the beginning with the label on the top, which is go to our document outline here in the lower left corner. Okay, here's our document outline. When we last saw it, it only had this one label in there. And now we got all these buttons added. You can see they're all selected, and they're all selected here as well. And we've got this little yellow thing up here. Now, if this is red, okay, if you do all this and this thing is red, well, that means that you've got not just warnings that your constraints aren't in the right place, but you've got errors, usually conflicting constraints, where you've asked auto layout to enforce two rules that conflict with each other. So if you get to that red, this is not going to work. So you'll want to start over, and I'll show you in a minute how you can restart over if things are not going your way. But if it's yellow, that just means things are in the wrong place, so no problem. We click the yellow. Here's all the things that are in the wrong place. This is all the buttons. You can see they highlight as I mouse over them. And you can really pick on any one of them to fix this, because there's a nice little switch here called Apply to All Views and Containers. You don't have to click on each one and have it frame update to the proper thing. You can just click Apply to All Views and Container, and it's going to move the frame of all the buttons to fix the fact that they're in the wrong place based on their rules. So let's try that. I'm going to hit this button right here, Fix Misplacement, and it moved them all. There's no more yellow. There's no auto layout issues. Okay, all looks good here. Close our document outline. If we zoom out, we can see, wow, it spread them all out, okay, because it's obeying those rules I gave it. Okay, so let's now run this on some devices here and see what this looks like. So sure enough, on an iPhone 6, which is a pretty tall device, it's made them, you know, kind of tall and thin. So hopefully it still works. 5, enter, 69,874 times, and 5 divide, maybe square root, something like that. It all seems to be working. Now, not only is it working here in this portrait mode, tall and thin, but if we go over here to this, we can rotate the device. Okay, so I'm going to rotate it left and right. I'm actually going to use the command keys to do this. So there we rotated it right, and we can see now it made the buttons spread out into this new location. Everything still works. Okay? And we can rotate back using the command keys here, and it looks good in either orientation. And in fact, it can look good on other devices as well. So let's go over here, and instead of doing an iPhone 6, let's try it on an iPhone 4S. Okay, so I'm just going to switch the simulator here. Let's run that. Now the iPhone 4S, you can see, is a little shorter. It's not quite as tall. A little lower resolution, obviously, but it relayed out the buttons to look good in that case too. So there's 9 times 9 divided by 8, square root, etc. And same thing here. We can rotate, and it'll look good this one as well. Okay. Alrighty, so the last thing I just want to talk about briefly is if you try this extra credit and it doesn't work for you, it gets all messed up, you can kind of start over by clicking on this and using the third button over here from the right. And this allows you to reset your constraints. And you can see the top section here is the selected views. I don't have any selected here, so this wouldn't do anything right now. But the bottom is all views and container. And I kind of recommend going down here to all views container and clearing the constraints entirely. Reset to suggested constraints are going to try and make some sense of your dashed lines, but if it's not working, your dashed lines are off anyway. So you can just go here and clear constraints, and I'll clear them all. Now that's going to clear not just your buttons, but also it's going to clear your label, so you'll have to reposition your label with blue lines, and then use Control Drag to set your top space and all that stuff. You know, if your buttons are really huge, they got really huge, but they're not in the right place, you can actually change the size of all your buttons in the Utilities window. If you go to the size inspector right here, that's this one, you can actually type in the width and heights you want the buttons to be. You can make them smaller again, which, you know, maybe 64 by 64. That might make them easier to re-drag them into position so that the blue lines are working. And don't forget the very important the blue line dragging, which is you want to take the whole grid and drag it so that it's sitting underneath your label. If you have a problem dragging the whole grid underneath your label, sometimes it's a good idea. Clear all your constraints, kind of move your buttons out of the way, just kind of move them down to the bottom here. And then just for your label, do reset to suggested constraints. This top one, selective views, reset suggested constraints. Because that will work for the label if you move it into position, as long as the buttons aren't too close and it thinks that you know, those buttons are near neighbors or something. And sometimes resetting it to suggested constraints will make it so that that bottom edge of your UI label will be attainable when you drag your buttons into position. But again, not to worry too much about this auto layout stuff. It's extra credit in assignment 1. It's not going to be extra credit in assignment 2. So you're eventually going to have to do it, and I'm going to be giving a big lecture on this in a couple of weeks on auto layout, because really I've only just shown you just kind of what it can do. I haven't really taught you how to do auto layout in particular. But auto layout is very important because, you know, we work in the square area and we want our UIs to work on all kinds of different devices. So that's why we're starting off from the very start with some experience with it. All right, so that is it. Now, later today, in this lecture, I'm going to give you a talk about this design paradigm called Model View Controller. And we actually designed our calculator kind of poorly because all of this code here is really nothing to do with UI. This is all calculator brain, calculator engine code. And this really wants to be in a different object, and that's what MVC is all about. And so I'll give a little talk about MVC later today, and then on Monday we're going to fix our calculator to obey MVC and be a proper citizen in the iOS world where all apps need to obey Model View Controller paradigm. So let's try and understand, half of you said that you already know MVC or you've seen it somewhere else, so this is going to be mostly a review, but the other half of you, this will hopefully give you an idea of what MVC is all about. So MVC is basically a mechanism where we divide up all the objects in our application into one of these 3 camps, okay? So the 3 camps, on the left there you see the model. So the model camp is going to be all the objects that are what your application does. So for our calculator, it calculates, okay? That's what it does. So all the parts where we're doing perform operation and all that stuff, that's all kind of calculator stuff. That should be in a calculator object somewhere else. It shouldn't be in our controller, okay? And then the second camp is the controller. So the controller controls how the model is presented on screen. And the view is the minions, the classes that the controller is going to use, kind of like the building blocks, the Lincoln logs. I don't know, maybe that's before all of your time, but you know, the things we're going to do to build our UI, we're going to use in the view. So the stuff that's in the view is pretty generic, okay, generic UI elements. The stuff in the controller is very specific to how your UI works, and the stuff in the model is completely independent of how your UI works, okay? So doing MVC right is about knowing where things go, but also about how to communicate between these 3 camps. And so I'm going to try and summarize how the communication works between these camps. And I've used road markings. You see the double yellow line and then the dashed white line. So that's like you're driving in your car. Try to use them as I have an image for how this communication happens, where it's allowed, where it's not allowed. Okay? So let's talk about the controller talking to the model. Okay, well, going from that side of the road over to the model side is a dashed white line. In other words, you can head right across there. Probably want to look before you go, but you can go right across, okay? The controller
has to know everything about the model, and it has to have complete ability to talk to the model, use its public API as much as it wants, because the controller's job is to present the model to the user using its view as its minions. So it has to have this access. So that's full unrestricted access the controller has talking to the model. This is a one-way error, one-way arrow from the controller to the model. And similarly, from the controller to the view is also unlimited communication, because the controller is responsible for using its own minions. The view is the controller's minions to lay out the user interface and all that stuff. So the controller can do anything it wants. I've put that little green word outlet up there because when we have a property of a controller that points into the view, we call it an outlet. Okay, and you're going to see that in the demo on Wednesday. I'm going to say, oh, let's create an outlet from our controller to our view so our controller can talk to its view. All right? What about this communication? Model to view? Never. And why is that? 100% obvious. The model is completely UI independent. So there's absolutely no way it could talk to a view object or anyone in that camp, because the view objects are fundamentally UI objects. They're kind of generic, but they're still fundamentally UI objects. Similarly, since the view objects are kind of generic, they can't be talking to any specific model. They need a controller to interpret a model for them. Okay, so there's never any communication this way. That's why it's a double yellow line. That's why these lines are red. That's why there's fire. Okay, never go across that line, ever. What about the view talking back to the controller? You got these generic view objects like buttons. Can they talk to the controller? Well, yes, they can, but they have to be careful because the view objects are generic. So they can't really know much about the controller. So they can only communicate back to the controller in a blind way, where they don't know the class or the thing they're talking to, and in a structured way, a way where we all agree we're going to communicate this way between the view and the controller. So what's an example of a structured way? Well, one is called target action. So the controller basically drops a target on itself, and then it hands out an action, which is like an arrow, to the view, and says to the view, okay, when you do what you do, like you're a button and someone touches you, or you're a slider and someone moves you, send me that action. Okay? So in this way, the generic button or slider is communicating back to the controller. It has no idea that it's a card game controller or a space game controller. It doesn't know what kind of controller it is. All it knows is that when something happens in itself, boom, it sends messages to the target. So that's a blind, simple, structured way for the view to communicate with the controller. Okay? But what about more complicated ways? Sometimes the view, things are happening in the view that are somewhat complicated, and the controller needs to be informed of what's going on, synchronizing what's happening. And one way to think about this is these words I put up here, will, should, and did. When the view is kind of like, let's say I'm a scroll view and I'm scrolling around, and I want to let the controller, somebody, know that the user just did scroll. Okay? Or the user puts down the touch and is about to scroll, I want to let the controller know the user will be scrolling. Okay? Or the user puts the touch down and the scroll view wants to know, should I allow the user to scroll here? Is that allowed? All those things, the scroll view itself might not have enough logic to know the answer to those questions. So what it does is it delegates the authority to answer those questions to some other object. Now, it doesn't know the class of that object. All it knows is that other object can answer these questions: will, should, did, this, that, or the other thing, like should allow scrolling, did scroll to point, things like that. So those are the kind of methods you're going to see in these delegate protocols. Now, I know that CS106A and B do not teach protocols. The word program. How many people know what the word protocol means in object-oriented programming? I can see very few of you. So I will be teaching that. A protocol is just a blind way to talk to another object. You're going to, when I teach you, you're going to be like, oh yeah, I know what that is. So we didn't really call it protocol or whatever. But that's how we do delegation, okay, this blind communication. Also, another important thing is that views should not own the data that they're displaying. They should not own it. In other words, it shouldn't be a property inside of them where that's the truth of that data. And the easiest example for this is all the songs in your iPod on your iPhone or your iPad, right? You might have 10,000 songs in there. So if you have some kind of generic list view in your view, you can't transfer all 10,000 songs to its instance variables and expect it to hold 10,000 songs so it can list through it. A, that would be inefficient, and B, that information, those 10,000 songs, belongs where? In the model, okay? Because your song database is a model. It has nothing to do with UI. It's just a list of songs and artists and albums and all that. It's in the model. Some controller has to look at that database and tell a view how to display all those songs. Okay, so we need that communication to happen here, and the view is displaying some sort of list, and you're touching down and you're flicking on the list and trying to see more songs. How does that communication happen? And the answer is we have another special kind of delegate, which we call a data source. Now, the data source doesn't do the will, did, should. It's going to be asking questions like count, like how many songs are there? And the controller looks in the model, 10,000. Response to the view. There's 10,000. The view makes space internally for 10,000 things. It doesn't know what they are. Moves the scroll bar indicator a little bit so that you know where it is. And then you start scrolling, flipping through it, and it starts sending the message to the controller. Give me the data at line 150, next 10 items. You see what I mean? And then you flick down some more. Now it's saying 250, 10 more items. And so the controller is going back to the model and saying, give me more data, and it's providing it to the view in this blind way. So you see how the view is getting data from the model through the controller in this kind of blind, structured way. Okay? That makes sense to everybody? So data source is just a kind of delegate. It's a specific kind of delegate for getting data. So you're going to see that there are classes in iOS that have a data source, and they usually also have a delegate. Most sophisticated classes in iOS have a delegate, the will, did, should kind of things. Some of them have a data source. It depends on whether they're showing a lot of data or not. Now, simple data, like if I had a view, if I invented a view for my card game called playing card view, and it just has a suit and a rank, okay, we're not going to do count data at for just suit and rank. We are going to set those properties. And so the view then would have that data set in it, but it wouldn't be owning it, right? The model would still be owning the suit and rank. The view is just getting that data to present it. Okay, so simple data we might transfer to the view, but it's merely for it to display it. Okay, this all adds up to the controller's job being to interpret and format the model data for the view. That's the controller's job. And when we do our demo, I'm going to be remarking like, oh, see, I'm writing this code. This is to make the controller perform its job, which is to take the model data and put it in using its view minions, put it on screen. Okay, that's what the controller does. What about this communication? Can the model talk to the controller? Again, obviously that's verboten because the model knows nothing about UI, so it couldn't possibly talk to a UI object like the controller. But sometimes things change in the model, and the controller needs to know about it. Okay, data changes, a database changes, or the model is some network database, and somebody changes something on the network, and it changes, and the controller needs to find out. So how do we do that communication? We do that using kind of a radio station model. Okay? So the model, a radio station concept, the model will use this concept to essentially broadcast information to anyone who's interested. Okay? And the mechanisms for doing this in iOS are called notification and key value observing, KVO we call it. And so the model can just say, oh, anytime something changes in my model, I'm just going to broadcast on my radio station. And then the controller simply tunes into that radio station. And it can find out things are changing. And when it finds out something changes, it's going to communicate via its green arrow to the model and say, okay, give me that data that changed. Right? Does that make sense? So towards the end of the quarter, we'll start seeing a little how to do notification to find out, for example, if the data in a database changes. We'll get a notification. The UI can then, controller can then go talk to the model to get the new info. Okay? Some people have asked, can a view tune into the radio station? They probably could, but you probably wouldn't want to do that. That would probably be a violation of MVC. All right, so we do this. We have all this nice communication and all these rules, and we can imagine building something simple using this. But what if we want to build a big complicated app, an app that has multiple screens on our iPhone or on an iPad? It's got 3 or 4 different areas on screen where things are happening. How do we do that? Well, we're essentially going to combine multiple MVCs, okay? Because an MVC can use as part of its view another MVC, okay? So an MVC, an entire MVC, can be one of the minions of some bigger MVC. Okay? And by doing that and cascading it down, we can build more and more complicated applications. So an example of this is you might have your calendar app, and it's showing you the entire year. And you click on a month, and now it shows you a month view. Well, a month view looks a lot different than a year view. A month view just has all the days and maybe some circle that tells you where you have an appointment on a day. And then maybe you click on a day, and now you get a day view. Okay? And the day is showing you the hours and what all your appointments are. And you click on an appointment, now you get an appointment view, and it's showing the detail of where you're going and when it is, etc. Okay? Well, each of those views, the year view, the month view, the day view, and the appointment view are their own MVCs. Okay? But you can see how the last three, okay, are used as essentially a minion of the top level view, the year view, to show more detail. Okay? So the year view, you click on a month, it's going to use the month view MVC to show more detail. So it's part of its view. Okay? So you see this also in iOS with tab bar controllers, right? You have the tab bar at the bottom might have 4 or 5 things you can choose. Well, there's some MVC at the top whose has 4 pointers to 4 minions, which are the 4 MVCs that are each going to appear in a tab bar. Okay? And we'll be doing that, for example, in assignment number 2 or 3, where we'll be making a tab bar, and you're going to have to do multiple MVCs. Okay? So that basically results in a picture that looks kind of like this. All right? Where you got this MVC, and you see the purple one that's like underneath the word together there, and it points to 3 other MVCs outside of its view thing. Okay? That's how we're going to build. So that might be a tab bar controller, and those might be the 3 tabs. Okay? And each one is its own little MVC, completely independent, operates on its own, doesn't even know. It's a generic, usable, reusable view-like thing at this point. Doesn't even know that it's in a tab bar. Okay? It just knows it's supposed to do whatever it does. And so it's modular in that way. You can also see that there's no communication between there's no other arrows except for some of the models. You see some of the models are communicating with each other. You know, a big application might have a single shared model, or the models might be split off into pieces to be used by sub MVCs. Okay? But that's the only kind of communication you have there. All other communication is either the structured view communication we saw in MVC, or it's using MVCs as part of the view of another MVC. Any question about that? So we definitely don't want to be having designs that look like this. Okay? Where everybody's talking to everybody, we can't tell who's talking to what. It's just impossible to debug a program like this, and it doesn't scale. You can't build really big programs this way. It just becomes impossible to know how touching anything would break everything, right? So we're definitely not going to be doing that.
All right, so that's MVC, and like I said, on Monday we'll apply MVC to our calculator. So what's coming up? I always try to get to this slide every lecture. Sometimes I forget, but it's posted in the slides. It says tomorrow is Friday. No, day after tomorrow is Friday. And people who are watching on iTunes U, these Friday sections will not be on iTunes U, so don't go looking for them. Only the normal Monday, Wednesday lectures will be on iTunes U. But for Stanford students, Friday we have this debugger section we talked about. And then next Monday, your reading assignment is going to be due. In other words, you should be done with that reading assignment before the start of Monday's lecture. And I'm going to assign you another reading assignment. It might be your only other reading assignment. Perhaps there'll be a reassignment 3, but it won't be any more than that. And then on Wednesday, I'm really going to dive into Swift and Foundation. I'm going to talk a little bit about the Objective-C legacy. And then your assignment 1 is going to be due a week from today. It's been posted for you. And your assignment 2 is going to go out next Wednesday and be due the Wednesday after that, just for a little bit of advanced planning for all of you. Okay? Any other questions? Okay, thank you.
For more, please visit us at stanford.edu. Stanford University.
Okay, well, welcome to CS193P, Winter 2015. This is lecture number 3. This is going to be all demo today. My voice is mostly recovered from last week, not 100% as you can tell, but it's getting there. So what we're going to be doing today is a demo. We're going to extend our calculator a little bit. We're going to make it more powerful. But more importantly, we're going to have it obey this MVC design paradigm. Okay? So it's a pretty good example of showing how we're going to separate the stuff into the camps here. And we're going to cover a bunch of other things, language features and stuff, as I always do. That's really the primary goal of these first 3 lectures worth of demos. It's just for you to see it in action, because you can read all you want about Swift or about iOS, but until you actually see it turning into an app, it's not real. So I'm just trying to make it real for you. I'm going to go to my last slide, because once I go to the demo, I'll forget to come back, which is just what's coming up in this class. On Wednesday, it's going to be no demo. It's going to be all slides. It's going to be one of the few lectures where it's all slides. But what I'm going to try to do on Wednesday is give you the highlights of all this reading that you're doing, okay? Because you're reading a lot of stuff, and it's sometimes hard to tell what's really important in there and what's not. So I'm going to kind of give you the highlights, and so you can get an idea of what's important. And then I'm also going to start talking about some of the foundation layer API in iOS. That's the non-user interface layer, basically, and kind of what some of the classes are in there. And then also just a little bit of how we use the language features of Swift and Foundation in iOS, so that you kind of get it's kind of your, next Wednesday's lecture, this is going to be your baseline lecture. It's going to kind of get you grounded in how to do all this stuff. And then next week, we'll start diving in to building more sophisticated iOS applications. Okay, I know this is kind of a whirlwind first 2 weeks. You're learning a new language, a whole new system, but hopefully by the end of this week and the end of your second assignment, which will go out on Wednesday, you'll be pretty confident that you at least have a solid ground foundation to build from. No pun intended there. There's a holiday weekend this weekend. No Friday section and no class on Monday, and so we'll resume next Wednesday. And the primary thing I'm going to do the next Wednesday, not the day after tomorrow, but the next Wednesday, is talk a little more about auto layout, because you've only just seen kind of a glimpse of auto layout so far, and I haven't even really told you how to do auto layout, and so you're kind of just fumbling around and kind of trying to reproduce what I do. So next Wednesday we'll talk about how to really do auto layout and all that. Okay, any questions before I dive into this demo? Hopefully my voice will hold out. I can already hear it starting to not hold out, but we will see. All right, so I'm going to just go to Xcode here, launch Xcode, and we're going to leave off right where we were last time in the calculator. Here it is right here. And so here's our UI. Hopefully you recognize that and you just did your homework, I hope. And here is this area that I selected at the end, which is this area that's really this is not about how the calculator gets presented on screen. This blue area is about how the calculator is a calculator. Okay, this is where all our calculations are. And this blue area really shouldn't be in this class, this view controller class, because this is the C of our MVC, okay? In our MVC, this is the C, this is the V, the view. These are the minions that this controller is using. And today we're going to create the M, okay, the model. The model is going to be what our application is, which is it's a calculator, okay? We're also going to enhance our calculator. The primary new feature we're going to give our calculator is that our calculator's model is going to remember every operand and operation you ever ask it to do, okay? So right now, as we do operations, we consume all the operands, okay? They consume, they're gone. So in this case, we're going to actually collect all the operations and operands in a stack, and then we can ask the model to evaluate that stack of operations and operands at any time we want. And the reason we're adding that ability is because of your homework, assignment number 2. You're going to add 2 major features where having all the operands and operations in a stack is going to be really valuable to you. So you'll be starting your second homework with what I do today, because you'll need this capability to do what I asked you there. Okay, and I'll talk about that at the end. If I forget to talk about that, remind me. Say, tell us about assignment 2. Okay, so how do we create a new class? Because we're going to put our model, okay, the calculator kind of get its guts in a different class. So how do we create a new class? In Xcode, we do that up here from the File menu. We go New File. So you're going to do File menu, New File for a lot of different things you're going to add to your project, not even just new classes or whatever, but when you click that, you're going to see there's a lot of different things you could add. And we're in iOS, so you're going to click on this iOS thing at the top, and we want to add a source file. And over here, we're going to be doing this later in the quarter. This is how we basically add subclasses of